Hello and welcome to our discussion on our next type of naming compounds. We're going to be looking at something called binary molecular compounds. Now, if you recall from our flowchart, we had talked about the fact that there were single elements that had a certain set of naming rules. And when we had two or more elements involved, we had a compound. Our prior work has focused on those that were ionic, which involved having a metal in the compound. What we're going to focus on today is if we answer the question, no, there is not a metal in the compound. And in order to distinguish between two different categories, we then want to identify, is the first element hydrogen? If it is not, we are going to be dealing with covalent binary molecular compounds. Molecular means covalent. So today we're going to learn how to name when you're given the formula and how to write the formula when you're given the name. So within our rules, you're always going to have two nonmetals. And the first one is typically the less electronegative nonmetal. And we're simply going to write that first nonmetal using a prefix for how many atoms are in the formula, with the exception of when there's only one. So when there is only one atom in the formula for the first element, we don't write a prefix. When we write the second name of the second nonmetal, we will use a prefix every single time, no matter what. Now, what prefixes, you might be asking? Well, we will show you. So there are prefixes here for 1 through 10 that help us to identify how many elements or atoms of each element are within the formula. When we did ionic naming, we determined the ratio of atoms in the formula based on charges. Because we are dealing with nonmetals, everything is really based on just how many are in the bonds, and we're going to learn about that a little bit later in the unit, but you can't do it based on charge. Let's say that I wanted to make a compound between sulfur and fluorine. Well, sulfur makes a -2 and fluorine makes a -1. These would not cancel out charge. There's no way to do it based on charge. So the name is going to use these prefixes to tell us how many, because otherwise there's no way to know. So big distinction between covalent and ionic compounds is that in covalent, we're told how many are in the formula. In ionic, we determine it based on charge. Nothing in the name of an ionic substance indicates how many of something there is. Now, there is a slight variation when we write names that have an A or an O prefix ending next to something like oxygen. For ease of saying it, we're going to drop that A or O. So let's say you wanted to write that you had one oxygen. Our prefix would be mono, and the word is oxide when you change it for the second one. We wouldn't say monoxide. It's a little clunky. We just say monoxide. So the MON is the modified spelling of the prefix, and oxide is the name of the element. We'll look at examples of that as we go through, and you'll want to make sure and check keys to make sure you're adjusting appropriately. So let's take a look at a couple examples here before I give you a chance to work on the ones in your notes. We here have P2O5. P is phosphorus. Our rules say that for the first element, use a prefix unless it's 1. Okay. It is more than 1, so we're going to use that prefix. So I'm going to write diphosphorus. Okay. And then for our second one, we have 5, which would be penta. And you know what I didn't put in the notes here that I need to adjust? Let's get to text here. One of the similarities with ionic is that we do change the ending of the second word to ID. So please just add that in. So diphosphorus let's get back to the pen. Penta would be my normal one, but because it's going next to O, I'm going to drop the A and simply write pentoxide. So diphosphorus pentoxide is our name for P2O5. Over here with SF4, we have one of the first atom, so we just write sulfur. This is where we do not include the mono. This is so common, it's one way to simplify the names that we don't have to constantly be saying mono sulfur or mono something else. Then 4 would be tetra. Fluorine starts with a consonant, so we say tetra. Let me move my video here. Tetra fluoride. What I would contend is that molecular naming is easier than ionic naming. That's actually kind of why we did it second, so that we can get the tougher one out of the way that takes a little bit more work, and then move into the simpler one where we're taking advantage of some of the patterns we already saw. For example, ending the name in IDE when you are doing the second word happens in all the naming for covalent and ionic. So that part's easy. We get to do that every single time. So I'm going to move to the next slide so that you guys can see the answers to the ones in the column on the right. I would encourage you to try a few of those before you check it. So pause the video at this point, do a couple examples, and then check your work. So a couple things to discuss here. I'm just going to get these all on the same page. So NO2 would be nitrogen dioxide. CH4 is carbon tetrahydride. What you're actually going to have to memorize, though, is that the common name of this is methane. There is another naming system for for compounds that are made of carbon and hydrogen-based compounds. They're called organic compounds. So it is much more commonly called methane because of that other naming system. NH3 isn't part of I forgot a space there. I was like, why does that look so weird? It is not necessarily its own class of molecule per se, the way that hydrocarbons are, but nitrogen trihydride has been known as ammonia for kind of like a long time throughout its history. And so it is much more commonly addressed by that common name. Notice it is not the same as NH4 plus the polyatomic ion. So this is where I like to distinguish between them. This is ammonium. So there is one extra letter, and the spelling's a little different, and there's an extra hydrogen in ammonium. The smaller compound, only 3 hydrogen, has the slightly shorter name, and there's just a slight difference in the spelling of the A and the U. So notice all the ones with only a single first element have no monos in the front. Dinitrogen pentoxide is our one for N2O5. Now, let's write some formulas. These ones are pretty straightforward. So the name tells us exactly how many of each are in the formula. All we have to do is format with the appropriate subscript. With the first element, remember that that nonmetal doesn't use a prefix if there's one. So if you see no prefix, just write the symbol, no subscript. If you see mono in the second element, we're going to just write the element same way, no subscript when there's only one. So when we look here at dicarbon, we see that di means 2. So I'm going to write C2. Hexa is 6. So I'm going to write H for hydride, C2H6. Sulfur doesn't have a prefix, so we know there's only one of those. And tetra is 4. Fluoride is F. So this would be SF4. Okay. Like I said, these ones are much more straightforward. The next slide will include the answers for those on the right-hand column of your notes. So please try a few and check. Once you finish, you should then move on to the additional practice looking at covalent compound naming. Our next video will then address our last category of naming, which is acids, another category of covalent compounds. So answer key posted. Please make sure you contact or get in touch with your teacher to clarify or ask any questions you may have as you are working on the practice.